Today I'm going to show you how to assemble a real solar station by yourself, and it's much cheaper than to buy a ready-made one, I should say. In this video I'm going to tell you how to make a small 220 volts power plant, which suits to the most of the gadgets. The first thing I need are the solar elements. They are also called the solar cells. Personally I prefer 2 or 4 ampere cells, but you may pick something else. The second thing I need is the body. It's usually made out of aluminum panels and glass, so the materials are in your local hardware store. The size of the body is determined by the size of the cells connected together. I'm going to use 60 solar elements, so 6 width and 10 height. You can measure up all the elements and find out the size of the glass you need. Then I cut the aluminum panels due to the size of the glass. It's going to be the framing for the solar panel. I cut it off at the angle of 19 degrees and then I glue it to the glass using some silicone adhesive. Next I make some angles to fasten the edges. Let's get to the soldering process. I find the copper Ethernet wire perfect as a solder. I think that soldering takes a big powerful soldering iron, because if it's less powerful than 40 volts, that won't be enough to solder the solar cells. I'm covering the places of soldering with the alcohol solution, rosin and tin. I remove the isolation and do the same to the wire. I slightly solder it in some places first, and then I can solder it thoroughly. That makes sure that the weld will be okay. This process takes accuracy and neatness. Keep in mind that the crystalline silicon solar cells are fragile. If you think you can't do soldering yourself, there are lots of ready-made solar cells on sale. Make sure your package arrives safely. Bad luck. 500 of cells were broken during the transportation. After the wires are soldered from the upper side, you can glue the elements to the glass. I'm laying them on the glass so they don't touch each other. And now I can glue them with the silicone adhesive.
Wow.
Now I'm soldering the elements on the back side. I fix it and make an output for plus and minus wires. I use a special combination of parallel and serial connection to get the voltage I need. Each element produces 0.5 volts or 4 ampere. I have connected 30 cells consequently and got 15 volts. And the same thing is done to the 30 remaining cells. I turn on these 2 groups of cells simultaneously to increase the voltage twice. Giving to this type of connection, the entire panel gives me 15 volts or 8 amperes. This configuration is perfect for charging up an accumulator of a car, for example, or a power supply for an inverter. Well, it's high time to check what we've got. The voltage of the load is 18.9. I'm switching on the device. Now it's 14 volts, you see? In other words, it's 6 amps. Very good. That's a really good result for the winter sunlight. The power of the resistor is growing. It's going crazy. And you can see the smoke right here. It just gets overheated. If only one element is defective, for example, there is a small crack in one of the cells, then the power will drop drastically. And in order to prevent it, we must check out each element under the voltage while the battery is running. If there are no leaks, it's okay. Now you have to protect the cells from the moisture and dust with a plastic film. And the solar battery is almost ready, and now I can provide with electricity a laptop or any 12 volts device. But that's not enough to call it a real power plant. We need an energy storage facility, so we could use some electricity at night, when the sun doesn't shine. We need an inverter for conversion of 12 volts to 220 volts. The accumulator of a car is a perfect battery. The amount of energy it can store is quite enough for the night time. But you can also connect 2 accumulators if you like, just to make sure that you won't stay without energy in a cloudy day. I have connected my solar battery through a diode, just in purpose my battery never lose its energy. I also shouldn't let the battery be overloaded, otherwise the electrolyte is going to be spoiled. To avoid it, I've assembled a voltage limiter. I connected it to the transistor and Zener diode, so when the battery is fully charged, the surplus voltage from the solar panel is going through a transistor into any power consumer, just like I connected. That's a light bulb from a car. You can also buy a ready-made charge controller. Its cost is $1 or something. I use an old interruptible power supply from a computer as an inverter. It gives 220 volts and up to 500 watts of power. The best place for a solar panel is the roof, or any other place sun reaches, of course. The best is to turn it to the south and tilt it about 45 degrees. It depends on your latitude, and in winter you should increase the angle. Seeing the sun is low above the horizon and it doesn't let the snow cover the panel. If a shadow falls on one of the cells, it reduces the current of the entire battery more than twice. This testing process, you see, has shown that the decrease of an angle up to 45 degrees doesn't influence the voltage the elements accumulate. This means that the battery works 6 hours a day with its maximum power. In a cloudy day it will also work. It will source the consumer and charge the accumulator, but not with its full power, because the dense clouds decrease the power of the generator 10 times. The wire connecting the battery and the solar panel shouldn't be longer than 3 meters, and the cable should be thick enough. The cable from an inverter to the battery must be very short and very thick as an automotive starter, and the connectors must be reliable. But the 220 volts wire can be any. That's basically it. Now I want to share you some experience that I've got using this little power plant. Although the power isn't so big, it is enough for the majority of devices and the electrical appliances. You can source the TV, a laptop, charge any mobile devices, use some lamps anytime. Seriously, you can use any electrical appliances with a consumption up to 500 watts. You can't use only the most powerful heating appliances and big refrigerators. Such a power station is ideal suitable for a detached house, houses on wheels, apiaries or farms. It can be used at any home to save money and energy, and in some emergency cases. This station is easy and cheap to make. I've built it almost for free. I made it using some junk in my garage. There's just one thing. One of my subscribers has gifted me the solar elements I needed. However, it's also cheap, even if you start from the scratch. But I don't stop here. Now I'm assembling a real big solar power station using the new technology which can source one or even several houses.